Okay, today's lesson is for chapter 11, lesson number 1, geometric sequences. So in the past, we had talked about sequences, but not geometric sequences. Previously, the type of sequence we talked about was called arithmetic, and that is the type of sequence where you're looking at the difference between the terms in the sequence. So in this case, the difference between these terms would be adding 3. So if I wanted to come up with the next term, obviously it would be pretty simply 16, right? Because we just continue that plus 3 pattern. Geometric sequences are different, not much more difficult though. A geometric sequence is a sequence in which the ratio of successive terms is the same number, and we call that number r. This ratio r is known as the common ratio. So let's take a look at some of these examples that I gave you to kind of identify what we're talking about here. So instead of looking at this as, well, I'm adding 3 and then hope that adding 3 again will get me the right correct third term, well, we in fact see that that wouldn't get me the correct third term because I'd have to add 12 to get the next term. So clearly that's not a pattern that we can follow. Instead, what we're going to look at is, what can we multiply that first term by? Well, if we multiply it by 4, then we get the second term. What can we multiply 4 by to get 16? 4. And what can we multiply 16 by to get 64? That would also be 4. So the common ratio, known as r, in this problem would be 4, excuse me. The next one's a little bit trickier, not too bad though. What do I multiply negative 9 by to get positive 3? Well, that would be negative 1/3. I have to change the sign, and then I'm becoming a third of the size. Same thing, what do I multiply 3 by to get negative 1? Well, that would be negative 1/3. What do I multiply negative 1/3 by to get positive 1/3, negative 1/3, and so on. Multiply by negative 1/3. So in this case, our common ratio would be negative 1/3. Now, obviously, that's great if I'm able to identify the common ratio, but there's got to be some sort of formula based on where I'm starting and what my common ratio is in order to figure out what a large term is. Like, for example, in part B, what would the 25th term be? Well, as of right now, we don't have the formula, but I'm going to show you that in a second here. So let's think about a simple geometric ratio. We'll start at 3, go to 6, and then we'll go 12, 24. Okay, I think it's pretty clear that we can see that our common ratio is going to be multiplying by 2. Okay, no, that's not so bad, but how does that actually work is the question. So if we come down here and we look at that sequence, what we see is we're starting with this first term 3. Okay, well, really, I'd like to think of this because there is a ratio here. That common ratio is still times 2, but it's times 2 to the 0 power. And we all know that 2 to the 0 power is 1, so this is really just 3 times 1, which is going to be equal to 3. Okay, so that's how we get that first term. The next term, I'd be multiplying the first term times 2, hence us multiplying it by 2 to the first power to get 6. Now, the third term is where it gets interesting because we're multiplying it by 2 to the second power. Because we first, again, you have to think of it as we're starting at 3, and then we're going to the second term, and then to the third term. So each of these would be times 2, and that's why we have 2 to the second power, times 2 again, which is how we'd get 2 to the third power for the fourth term. And obviously you can see that if we look at the, let's try to pinpoint this here. If we look at the exponent, how does the exponent compare to the term? Well, the exponent is always going to be 1 less than the term I'm looking for. So in the third term, the exponent is going to be the second. The fourth term, the exponent is going to be the third. And the nth term, and this is important, it's going to be to the n minus 1. So that leads us to this formula here. N is the term number. A is our starting number. And I should actually write that because it's not on here. A is the starting number. And that's important. So if I'm looking for A sub n, then n is the term number. So for example, if I go back up to this example, if I want to know what A sub 7, that would be the 7th term of this sequence up here, right? So then I would just follow this through. Well, I start with the first term, which is 3, multiply it by the common ratio, which is 2, raised to the n minus 1 power, which would be to the 6th power. So real quickly, 2 to the 6th power is 64. So we'll get 3 times 64, which would be 192, would be the 7th term in this series. So that's not too bad. And that's really it. That is pretty much the entire lesson. That's geometric sequences. Just as another example, we have a geometric sequence here, and the first term is 500. So I'm going to label this, or why don't I just do this? I'll just say, okay, A is 500. Okay. The common ratio, R, is 0.2. And the term, the n value that I'm looking for, is the 7th term. Okay, so you know me, I like to write the formulas. So A sub n equals A sub 1 times R to the n minus 1 power. Well, if I fill everything in, A sub 7 is going to be equal to, our starting term is 500. I actually should list this right here as A sub 1. Starting term is 500 times 0.2 raised to the 6th power. So let me break out my calculator here off screen, and we have 0.2 to the 6th power is going to be 500 times 0.0000064 for a grand total, when I multiply that by 500, of, and I'll zoom this in a second, 0.032 would be the 7th term of this geometric sequence right there. And that's really it. I mean, follow the formula, pay attention to what term you're looking for. Remember that you're raising it to the n minus 1 power, and you should be good to go with geometric sequences, which is another type of sequences that we can now add to our bag of tricks. Thank you, and that's the lesson for today.